Hello everybody, I am Dr. Chirma Kumar Saw. In the non-conventional machining series, this is the first one, that is abrasive jet machining. Prior to that, we should know what is abrasive particle. Abrasive particles are very tiny particles. These are the tiny particles. This is normally made of L2O3, silicon carbide are the few examples of the abrasive particle. And we have already observed it, everybody. It is in common. One example is the grinding wheel, which contain a very small particle. Okay, you can observe it that very small particle is just bonded with some bonding material, and it is used to remove material. This abrasive particle has a few properties just like high hardness, so it is can be used for the polishing process, cutting process, and machining process. This abrasive particle is here is used for the machining process. But how it is used? The process prior to that we should understand the simple basic principle. This is by with the help of simple example of the gun and a bullet. We know that the bullet has a very less weight. It is the example just like the 7.5 gram. When it is fired through the gun, it can cause a huge damage. How? Because simple formula of the kinetic energy. We can observe that kinetic energy is equal to half mv square. Here one factor matters is the velocity. If velocity is high, kinetic energy is very high. The small weight bullet can damage a great. This principle is used for the machining process. Here in this abrasive jet machining, this work as described earlier principle. Here small abrasive particle is thrown at a high velocity. When you strike the workpiece, it causes damage to the workpiece. So this is a simple schematic of abrasive jet machining process. First part is the compressor. Compressor what it do? It draws the air from the atmosphere and compress it at a higher pressure. Instead of air, we can use any type of carrier gases. Then it is passes to the mixing chamber, and the upper part of the mixing chamber, abrasive particles are there. They are mixed with the proper ratio as per the requirement. Remember that the high pressure gas is used to only carry the abrasive particle. Then it is moved to the nozzle. Nozzle is used to, it is the most important part, it is used to increase the velocity of carrier gas. Okay, when the carrier gas velocity is increased, that means the abrasive particles velocity also increase. The high velocity abrasive particle simple strike to the workpiece. The velocity is high up to 300 meter per second. It is a very high velocity. It can also meter per second up to. Okay, this can damage the workpiece. So simple thing is that we can clearly observe from this large figure, this diagram, when the abrasive particle passes through the nozzle, it strikes the workpiece. Small part of the workpiece is damaged or the removed by the strike of the abrasive particle, and the carrier gas also remove the damaged part or the chip. So during this process, thousands of abrasive particles comes through the nozzle and strike the workpiece. So that each particle remove a very small amount of material. So combined effect is removal of the large amount of material. So where we can use this process? This process is used for the cutting of the brittle material like silicon and germanium. Silicon and germanium is mostly used in the electronics industry, and it is famously used for the remove paint corrosion layer from the surface. This is one of the example. Deburring small hole and cutting small slot in hard material. But this process has certain limitations. Just like that, it is difficult to machine ductile material by using abrasive jet machining, because ductile material are the soft material. When you attack the soft ductile material with the help of the abrasive particle, it will simply enter into the ductile material and stick there. So machining process may not be takes place, or machining efficiency is very less. So it is normally avoided for the ductile material. Second one is that abrasive particle cannot be reused, because it is difficult to collect the abrasive particles, and when it is collected, it contains the removed material part or the chips, and second part is the um, broken abrasive particles also. Third point is that environment issue. That means that when there will be a huge dust will be around the machining part. So a closed chamber is required to avoid spread out of dust. Last one is the low accuracy process. Okay. Due to the tapering effect, because the abrasive jet do not flow in a same streamline. It is sometimes due to spreading effect in direction also little bit changes. Later few factors are also there which affect the machining process. In very short, I am describing it. First one is the stand-off distance. What is stand-off distance? This distance. Okay, this distance is known as stand-off distance. If this distance is less, the abrasive particle cannot get enough acceleration to strike it. Okay, so it should have a some minimum distance. If distance is more, what will happen? There will be a spreading effect of the abrasive particle, so it will be also ineffective. So stand-off distance has a very importance during the machining process. Another one is the abrasive type and size, because when you are using multiple type of abrasive particle are there, just like example I have already told you. One abrasive particle name is L2O3, another silicon carbide. These have a different property, different hardness, and you have to choose carefully. And what size of abrasive particle you are going to use, that also defines your the machining MRR. Another one is the surface quality. Another important was the carrier gas, pressure and velocity. If you have a high velocity, then it can, or abrasive particle can move in a very high velocity and strike with a higher kinetic energy. So we require high velocity, high kinetic energy, we have to provide a high velocity of the carrier gas and nozzle material. As I have already told you that this abrasive particle has a high hardness. So for that high hardness, so what we have to do? We have to make the nozzle with a greater care and with a very better material. Normally tungsten carbide is used as a nozzle material. This is a very limited knowledge what I have described here, but if you want to know more, then you can follow these two books. These are the very good book in the conventional machining. After that also you can follow a lot of books, just like a lot of books are there available. You can follow any book. Okay. Thank you and have a good day.